Hi, I am Syed on Maths Online. Today we'll be discussing about some problems on the differential equation. We already seen in the previous videos how to find out the complementary function and particular integral. Now we'll try to solve problems where we are going to find out both the complementary function and the particular integral for non-homogeneous differential equations. So this is mixed type of problems. Solve dq plus 1 times of y is equals to cos of pi by 2 minus of x plus e power of x. Let us write down the auxiliary equation. Auxiliary equation for dq plus 1 will be mq plus 1 is equals to 0. So let us try to find out the roots of this auxiliary equation. We can go for more, choose the equation. It's a cubic equation, therefore option number 4. Coefficient of m cube will be 1. Then coefficient of m square will be 0. There is no m square, therefore coefficient of m square will be 0. Then coefficient of m is not there, therefore coefficient of m will also be 0. Then the constant term is 1. So now try to see the roots. So you can see the first root is minus of 1. The next root will be half plus root 3 by 2i. Then half minus root 3 by 2i. So these are the three roots. M is equals to minus 1 and m is equals to half plus or minus root 3 by 2i. So this is the complex roots in pairs. So now the complementary function will be, for minus of 1, the complementary function will be c1 e power of minus of x plus, this is a complex roots, therefore you have e power of half times of x into, it is c2 cos of, you have root 3 by 2, so root 3 by 2 x plus c3, it is sine of root 3 by 2 times of x. That is the complementary function. Now let us go for the particular integral. Particular integral will be 1 by, so you have the operator as d cube plus 1, it is d cube plus 1 times of, the right hand side value that you have is cos of pi by 2 minus of x plus e power of x. So let us try to multiply this one. So it is 1 by d cube plus 1 is multiplied by cos of pi by 2 minus of x plus this again multiplied by e power of x, it is 1 by d cube plus 1 is multiplied by e power of x. This can be written as 1 by d cube plus 1. This is in the form of cos of 90 minus theta. So cos of 90 minus theta will be sine theta. So therefore we will be getting sine of x plus this value 1 by d cube plus 1 times of e power of x. So now we need to find out the particular integral of this sine ax form and e power of ax form. Alright, so these are the two types we have. So let me take the first term to be p1. Let us take the second term to be p2. So we'll try to evaluate p1 and p2. So let us take this as equation number 1. So first we'll try to evaluate p1 value. So p1 will be 1 by d cube plus 1 times of sine of x. Now this is of type 2 where it is in the form of 1 by f of d into sine ax. So we have the pi value for 1 by f of d times of sine of ax, or rather we'll take f of d square. So here we are going to replace the value of d square by minus of a square. Right, d square has to be replaced by minus a square. So here if I want to replace this d square by minus a square, so we don't have d square. First I will try to write down this d cube in the form of d square. So I can write this as d square into d, and this plus 1 times of sine x. So let us try to replace this d square. Replace d square by minus of a square. So what is a value? That is coefficient of x. You can see that coefficient of x is a value. So here coefficient of x is 1. So it is minus of 1 square, which will be minus of 1. So replace d square by minus of 1 here. So we get the value as 1 by d square will be minus 1 into this value of d as it is plus 1 into sine of x. So this can be rewritten as 1 by, so first I will write the positive value 1, then 1 minus 1 times of d will be minus of d into sine of x. Now I need to rationalize the denominator. Rationalize the denominator. So which can be written as 1 by 1 minus of d. So the rationalizing factor will be 1 plus d. So multiply by 1 plus d, divide by 1 plus d. Sine of x will be as it is. So this will be equals to 1 plus d divided by. The denominator is in the form of a minus b into a plus b. It will be a square minus of b square into sine of x. Now again we will try to replace the value of this d square by minus of a square. So replace d square by minus of a square, which is minus of coefficient of x is 1, so 1 square will be minus of 1. So if we try to replace over here, we have 1 plus d divided by 1 minus d square value is minus of 1 into sine of x. So this will be equals to 1 plus d times of, you can multiply that by sine of x divided by the denominator you have minus of minus will be plus, so 1 plus 1 will be 2. Now the numerator has to be simplified over here. So multiply this 1 with sine x, so we'll be getting sine of x. Multiply this d with sine x, so d times of sine of x whole divided by the denominator 2 as it is. Or further, if you try to simplify, the sine of x will be as it is. Differentiation of this sine of x will be cos of x whole divided by 2. So we have got the first particular integral, that's the value of p1. Now we'll try to find out the value of p2. So the value of p2 will be, so you can observe over here, this is the value of p2. So the value of p2 is 1 by d cube plus 1 into e power of x. So it is 1 by d cube plus 1 into e power of x. So we know the type 1 particular integral, 1 by f of d into e power of ax. So in this case you have to replace the value of d by a. So if you try to replace this d by a, you will be getting the value to be equals to 1 by f of a into e power of ax, provided that the denominator is not equals to 0. Alright. So if you try to replace over here, replace the value of d by a. So what is a? So coefficient of x over here is 1. So replace the value of d by a. So we get the value of p2 to be equals to 1 by d value is 1. So 1 cube will be 1 plus 1 into e power of x. So we get the value to be equals to 1 by 2 times of e power of x. So this is the value of p2. So we have got p1 value, we have got p2 value. So substitute the values of p1 and p2 in equation number 1. So your equation number 1 will imply particular integral is equals to, so p1 value you have got it as sine of x plus this value, sine of x plus cos of x divided by 2, sine of x plus cos of x divided by 2 plus p2 value is this, it is half times of e power of x. Now we can write down the final solution. So we have the solution will be y is equals to CF plus PI. So y will be equals to, your CF value will be C1 e power of minus of x plus e power of half times of x or x by 2 times of, you have C2 cos of root 3 by 2 times of x plus C3 sine of root 3 by 2 times of x plus this particular integral. I will continue here. Plus, so the particular integral will be sine of x plus cos of x divided by 2 plus half times of e power of x. So that will be the required solution.